Hi, in today's video we'll be doing intermediate OpenRocket. We'll be covering off how to use the simulation further and also how to optimize your rockets automatically. We'll show you some cool tips and tricks to help you along the way and to make your life easier while using OpenRocket. Okay, now we move on to flight simulations. In here, we'll press New Simulation, and in here, we can further edit the simulation. We have to change the launch site latitude and longitude. We can also change the wind, atmospheric conditions, and also the launch rod dimensions. With the simulation configuration, let's start by getting the launch site correct. I'm going to switch over to the internet browser. In New Zealand, this is our club launch site. It is in the middle of the North Island. Now, to find the latitude and longitude, you can find them up here in this area. Now, the latitude is first, and the longitude is second. So I'm going to start off by copying the latitude. And now I'm going to put it into OpenRocket. Now you can see that I've pasted in the latitude and longitude. You can see that it's rounded up to 3 digits. These numbers will be different depending where you are in the world, and make sure that you get it absolutely correct. Now, to find the altitude, you can either find it in Google Maps on the terrain mode, or you'll just have to search it up if you can't see the elevation. Now for this, it was 18 meters high. Now we move on to the launch rod. Now this is important for the stability when it comes off the rail. Make sure that you get the correct length. This angle here is for the launch rod. Make sure that you've got that correct. It is not for the wind. For the length of the launch rod, don't forget to take into account that the rocket could be off the bottom. Now we're going to save these parameters as default so that we don't have to set them each simulation that we make. Now don't forget that you might want to take into account the wind. However, I wouldn't do it if you don't know what the wind is like. Now keep in mind that you can change the atmospheric conditions. If you feel strongly about it, then change it. I'm going to change this to 15, and I'm going to press Save as Default. Remember that you can override your last saving as default. Now before getting the simulation plotted, we need to make sure that there is a motor. I'm going to choose C65. Now I'm going to simulate and plot it. Alrighty, now we're going to analyze this pane. In the x-axis type, we have time. This is usually what you would do, however you can change it to whatever you want. These are the y-axis types, and you can create a new y-axis plot type. In the flight events, you can add things like launch, liftoff, launch rod clearance, and so on. This is just a marker at a specific time. Now I'm going to press plot. Okay, now that we have our simulation open, I'm going to resize it to make it bigger. Alright, that's good. Here we have our simulation. Let's get into it. The blue line is altitude, the orange line is vertical acceleration, and the yellow line is vertical velocity. Okay, now we're going to focus on altitude. We can see there that it hit an altitude of 313 meters. Now we need to check the descent rate of this simulated rocket. We can measure it from the very top at apogee to the very bottom at ground hit. From checking our descent rate, we can see if it's within the club's rules. The rules will change depending on the weight of the rocket. You must ensure that your parachute is correctly sized, as it must give you the correct descent rate. Now, if your rocket is going too fast towards the ground, the simulation will give you a warning. You can see it over here. If you just hover over the simulation, then you can see the warning that it gave you. Over here on the very right column, you can see the ground hit velocity. Now to go back to the simulation, you simply go back onto it and then press plot. It'll do the same thing if you haven't changed anything. Okay, now we move on to vertical acceleration. Keep in mind that this is not speed, rather acceleration. We can see here that the engine ignited and the engine was burning in full force and it went down, and then the engine stopped burning. With this very, very low spike, we can see that this was a deceleration from the ejection charge. From there on, it should be zero acceleration, as the parachute is dragging it down and there's nothing else pushing it. Now we move on to vertical velocity. This is speed, but it's called velocity. Make sure that you read the numbers from the right on this one. This is very important, as if you read over here, the number would be way, way too high. Now let's find the maximum velocity of this rocket. We can see on the y-axis on the right-hand side that it went about 90, but if we hover over it at the very top, we can see that it went 91.88 meters per second. Now from peak velocity, we can see that it goes coasting. This is when it loses most of its velocity. From here, we can see that while it's slowly gliding down, we can see that this is the descent rate. It's just below -5, which looks correct. Okay, now we're going to look at some simulation errors. If we close this here and close that, the main warnings that you will get are either from the velocity off the rod, the velocity at parachute deployment, or the ground hit velocity. Now, what the red dot means is it's out of date. This means that you've changed the rocket after the simulation. Now with simulation 6, we can see that it is yellow. This means that we haven't chosen anything to plot yet, and so we need to go simulate and plot, but we've figured out that it has no motors, so I'll quickly change that. And then, if we press plot, then you can see it turns green. I'm going to exit. Okay, let's see what the exclamation mark is. If we just hover over it, we can see under warnings that the recovery device deployment at high speed was at 106 feet per second. This is because the parachute deployed while the rocket was still coasting. Alright, now we're going to go back to rocket design to see what else we can do in there. Okay, let's say that you've launched the rocket. What's gonna happen now is you're gonna compare it against the simulation's apogee. If it's a bit far off, then what you can do is you can go into the nose cone. From there, you can go into override. From there, you can press override the coefficient of drag. What the coefficient of drag does is it increases or decreases your drag amount. So if I raise the coefficient of drag, then you lose altitude because the rocket has more drag. If I lower the coefficient of drag, you gain altitude because the rocket has less drag. Now look at the apogee and see how it changes as I increase or decrease this. I increased that slightly, and now I'm going to decrease it into the negatives. You can see that it went much higher. Keep in mind that the point of overriding the coefficient of drag is to match your rocket simulation with reality. Now, I'm going to focus on override for all subcomponents. If I press this doesn't do anything, because what a subcomponent is it's a component that fits under one of these components. For example, the body tube has all of these subcomponents, and the inner tube has this subcomponent, whereas the nose cone has no subcomponents. Let's say that I wanted to override all of the rocket's coefficient of drag. I'm just going to untick the override coefficient of drag here. And what we can do is we can go into the sustainer, and we're in the override, and I override it, and I press override for all subcomponents. If I change this very slightly, look at the apogee. Now if I change this even more, it goes up lots, but I'll cover why later. Now, over here in this panel, we can see that there's CD markings. This is an indicator to show that you have an override on, and it's the coefficient of drag override. The reason why all of these are gray, except the sustainer, is because this is the main thing that you have overridden, and these are all of the subcomponents. If we untick override for all subcomponents, then we can see that the CD that are gray disappear. Did you notice how the apogee changed up? That is because when you override the coefficient of drag for all subcomponents, the ones that have a higher coefficient of drag get lowered. That was why the apogee went up so much. You can see there that it just went 200 meters higher. Let's go and look at the coefficient of drag on the body tube. If we go into override, we can see what it was there. It was 0.394. When that gets lowered to 0.060, then what happens is the coefficient of drag goes down massively. Keep in mind that when you override the coefficient of drag, you are overriding what the simulation has calculated. This means that you need to tread carefully. That covers off showing the coefficient of drag. Okay, now I'm going to show you how to get a photo of your model. In Tools, you can find Photo Studio. Now, we can see our beautiful rocket with a background. In the Settings tab, you can change any settings that you want to change. You can change the pitch, yaw, and roll, and also how advanced it is in the picture. Now, if you want something cool for the back of the rocket, I would go Effects. But we can also change the environment. with the sky image, we can change it. Now I'm going to fiddle around with the effects. Okay, now I've made the photo. This is what it looks like from far away. We've gotten a sick photo of a rocket. Okay, I have pulled up the example rocket, and so now what we're going to do is we're going to go into Tools, then Rocket Optimization. Now, when we're in this panel, the first thing that you're going to do is you're going to look at Optimize Simulation. You're going to need to have a simulation to actually optimize. Now, you can have an optimization goal, which is maximize value, minimize value, or seek a value of X. Now, the optimized value, that can be the height that you get, your stability, or maybe even your total flight time. For now though, I'm just going to have apogee altitude. Now, make sure that you have the required stability set. I'm going to change minimum stability to 2.3 and maximum stability to 3. Now, in the available parameters, this is where we're going to be adding stuff to optimize. I'm going to go into the trapezoidal fin set. I'm going to add height, root chord, sweep, and tip chord. Now, something else that I also want to optimize is the nose cone. I'm going to go length and shape parameter. Now, these are where you have the parameters that are being optimized. You have the current, minimum, and maximum. Now make sure that you don't have the nose cone being too short, because sometimes what it likes to do when you only have the nose cone length selected as a parameter to optimize, it goes for as short as it can. Make sure that you have these correct. I'm going to change the minimum to 8 and the maximum to 14. Now with the sweep, I'm going to change the maximum to 2. Actually, because of the current, I'll change it to about 3. The minimum, I'll make that 0. Okay, now the height, I'll make that 2.5. And then this optimization seems very good. Now what we're going to do is we're going to come over here to start optimization. Now before we press it, we're going to look at this image here. This is the rocket as it currently is, but when you press start optimization, you can see all of the steps and changes that it makes visually. Now I'm going to press start optimization. Now it's finished. We can see that the best value it got was 332 meters. If we have a look at the rocket, it doesn't seem to be looking the best. And keep in mind, if it's looking very, very out of shape, then OpenRocket has probably thought that it's good, whereas it's really not in real life. Now keep in mind that optimizations can go wrong and something gets extremely shortened or extremely lengthened, or it can go very well with your rocket being optimized just a bit without the looks being changed much. we can see here that the fins don't look too good. If I press reset, then it resets it back to normal. I'm just going to press close. I'll show you what it looks like if we just optimize one thing. I'm going to go rocket optimization, make sure we have the simulation, and then I'm going to go 2.3 to 3 cal. Apogee altitude is the maximized goal, and then I'm going to select nose cone length. I'm going to make the minimum 0.1 and the maximum 100. Let's see what it does. Look at the nose cone. We can see that it went 3 meters higher, and it's changed the length slightly shorter. Now, I think that is good. However, I personally prefer having a longer nose cone. To check if the simulation isn't going very well and it's going to the very minimum of what you set it, change the minimum to something bizarre like I did, like 0.1. If it goes to that, then you know that the simulation isn't very good. And that's it for today. Hope that you learned something new in OpenRocket. I hope this tutorial helped you gain a deeper understanding on how OpenRocket works and its deeper features. See you in the next video.